Hello, let's get started. So I hope the frame rate is not too bad. I forgot to switch off my VPN, which is like a struggle because like I want to have my VPN on all the time, but sometimes just don't agree with my streaming and it's just frustrating. So yeah, if it's going to and the thing is like if I switch it, then like I have to stop the streaming and then start again, which is again like something that I don't want to do. So yeah, it's just a nightmare. I really don't know how to deal with it. And yeah, but anyway, we are here. We are doing the Python 0 to Hero again. Like this week, we got to just cover things that we didn't talk about list and dictionary last time. We go around like to talk about them. So yeah, I hope that is going to be interesting. So um, right, so I have to redo this recap wall a little bit because yeah, because it's just like too overcrowded. And I try to like make it smaller and have two columns so I can put more stuff in there. And hopefully we keep like making this bigger to have more topics that we have learned. And yeah, so it's kind of like a wall like of achievement. So we kind of like know what we've done. Um, Right. So first of all, a list. I think this is kind of like something that we have talked about last time, but I want to revisit it. So the interesting thing about list is mutable. So you can change what's inside a list, and you know, so lots of things that happen to list is that like the operation on it actually change the actual list like itself. So it won't like rather than a mutable object, if you do some operation on it, actually it will become something else. So you would come across cases that you make some changes to a list that you don't have to reassign it to a new list, but you would you so it would just like you know, mutated itself, right? Mutated the list itself. If you later code that same list again with the same, you know, addresses and reference, the things will change because we have changed it. Um, and it's not hashable is another characteristic of list. And if you want it to be hashable, you have to use tuple. So yeah, so they just behave differently in that sense. Um, String is hashable. And oh, by the way, yes, a list is a sequential object. I put it in the next slide. And yeah, so well, list is a sequential object. It means that because I think now since we learn how to look at what's inside a Python object, it will get it has to get item you know method inside as a default is kind of the kind of a definition of like what is a sequential object. And yeah, it's iterable, so you can like basically, well, if you look at it, it will have the iter object that you would call, you know, and it just so it's iterable is itself, so you can actually have the next function to next method to put it into, so it's an iterator, you can put it into a for loop, right? So we all learned all these things like a few weeks ago. And also it's ordered, so it can be sort. So there is an order to a list. So if a list like you can have 1 2 3 and 2 1 3, they are like they have the same you know, elements in it, but because the order is different, so you can't say this two lists is the same, right? 1 2 3 and 2 1 3. So so that's the characteristic of an ordered object, and that's why the order matters, and it can be sorted. So let's actually have a look. So I have opened a Jupyter Notebook here that is basically we can do some thing with it, and I would rename it 2020. What's the date of today? Oh, it's like almost the end of August. So like today is actually super cold. For me, it just feel like um yeah. So for me, it's feel like uh winter already. Like even yesterday, it's like super cold. So summer's gone, and I feel a little bit sad about it. That like I really like the summer weather. I'm from a place that is in generally like not too cold throughout the year. So like this is like winter for me. Like, you know, 12 degrees. This is definitely winter. I know in some places it's not, but yeah, for me it is. So and also it's always dark. It's like not enough light. Good thing is I don't have to put sunscreen when I go out, but still, you know, is not very happy. So So let's have a look at the list, and we can kind of explore a little bit of its characteristic with this Jupyter Notebook. So let's create a list. My list is, let's say, 1, 2, 3. So that's super simple. And you will see that my list would be, so this is like, I know I'm like repeating a lot of things I've talked about in previous episodes, but I'm just trying to kind of recap, so for people who missed the previous episode, they will still get this information. So inside my list, you can see that what we are talking about is that I get the get item here. That's basically, it's, I think I spelled it wrong here, is it? No, okay, it's rare. I usually spell things wrong. Okay, so the get item here, basically what it's doing is that if I have my list, if I call this get item, let's say I call it 1, okay, so what I would get is this, actually, because like it's the same as my list 1, this will give me 2, right? So because this is 0, 1, 2, so this is the second thing in my list, which is 2. Okay, so another thing is that it got the iter. So if you want to check, so my list equals to my list dot iter uh, yeah. So well, it's not the same thing, but what so I think, yeah, it's not the same thing, but all right, yeah. So sorry about that. Like an iterator will give itself as an iterator, but yeah, but a list object would give an iterator that loop for itself. Sorry, I was a bit mistaken there. Yeah, but it got the iter object that would give an iterator there. That in this iterator, actually, you will see that it would get the next method. So yeah, so it would have the next method for in this iterator here. Yep. So it would actually give out. So you can put this. So like, what happened if you put a list in the for loop is that the for loop will actually call this thing here and get an iterator from the list, and then it will just like, every time it go through the for loop, it will just call the next to get the next value of it. So basically, it's just looping through all these elements one by one, 1, 2, 3. Okay. Yeah. So basically, well, you can do the same thing here. That you can call this, my list iter equals to this, and then what you can do is like my list iter dot next. No, actually, yeah, you can call like dot next like this. No, yeah, like this. Or actually, you can just like, for example, this one you can also do it like here. So usually all these things that is a built-in method, they will have a built-in Python function that come with it. So you can actually do this to call the next of it. And this is, the first time we call it, so this one. And if we call it the second time with a different way of doing it, it'll give me 2. And if I do it again, so it'll give me 3. And if I do it again, then I would have a stop iteration. So this is how an iterator behave, which is absolutely fine. So the next thing I want to look at is the list, the order matters. So remember my list is 1, 2, 3. So let's check that if this is equals to 2, 1, 3, right? So, well, I think you're expecting it's not the same thing. So this is a characteristic of an ordered object. So later when we look at dictionary, we'll see that this is not true for a dictionary. But dictionary is not ordered, so it will behave differently. So I'll just stop it here, and then later we come back when we look at dictionary, okay? So yeah, so this is actually related to the thing that we talk about later. So that's why I'm spending time to explain things. So the first thing that I want to talk about that is actually something about list that we didn't talk about last time is that list comprehension, right? So what is list comprehension? I would say that is, you can think of it as a shortcut to create a list in a Pythonic way. So for example, this is an example I found from this tutorial, which is quite a good tutorial that I will go through later. So yeah, like what this is that this is a for loop that is creating a list that is picking the letters from human and make it into a list. So let's have a look at it, right? So if I could, oh yeah, I know what happened because I'm not in the present mode, but that's fine. Right, so list comprehension. Here that we gotta, yeah, just try to make things very organized so like you can download it afterwards. So this one, so let's print the H letter here. Oops, my typing is horrible and the indentation is not correct for some reason. Right. So you can see that I'm just breaking up this string into like letter by letter, HUMAN human. So yeah, this is a way of like creating a list like this, right? But we say that this is a way of doing it, but this may not be the way that you want to do it because it takes, you know, it takes some time to write a for loop, and then also you have to append the letters, which you may not like. So another way of doing it is to use list comprehension. That basically is like compressing everything in one line. So basically, this is doing exactly the same thing. So if I print out H letters again, right. So yeah, it's the same thing. So okay, let's talk about the syntax of list comprehension. So you would use a for loop somehow, of course, because well, it's still a for loop operation. You just compress it. So you loop through everything in human, and then what you want to be an element in the list, you just like put it here. So let's have a look at this tutorial, which I really like. And yeah, but the thing is like got the cookie and things. Usually I just check that I want to minimize the cookie, and yeah, right. So yeah, so this is the syntax in kind of like a sense that is called let me make it bigger, maybe that's better for you, expression, and then like for the item in list. So it could be, for example, in this example here, that I could change it. So I could be like, oh, I want the uppercase, so maybe sorry, letter dot upper, then it would become all uppercase. So this is an expression of like what it actually would be for each one of them, right? So yeah, and then so item in the list. So for the item, you can do something with the item, and then it become the actual thing. Yeah. So you can actually use it in a lambda function, like I did here, like I did before that. If you remember what is a lambda function from last week. Uh, so yeah, basically it's the same as a lambda function. So you can actually here you can do a lambda. So yeah, so basically is mapping it as if we're using a lambda function here. Um, so yeah, I don't know how to say it, but like we did a lot of this last week. I can open the notebook from last week and show you. I think right. I think it's from yeah. You see the lambda function. We're just like taking the square of it, and yeah. So remember what we did is that we have 1, 2, 3, and then we would want to make the square of it and map it, and it will become a mapper, and we can cast it into a list again. So let's copy this here. So for example, this is my list. My list is 1, 2, 3, right? So it's the same thing, and it give 149. But we can also again do the list comprehension. So it will be n square. That's what we want, right? And then we'd have 4 and in my list. So this will give us the same thing. So yeah, this kind of like a shorthand for this. You can also think of it that way. Um, and other thing is that yeah, you can actually filter things as well. Remember we used filter before, right? Let's go back to what we were. We use filter, for example, this. I want to filter out, the This is a new my list. I'll copy this over. This my list 2. And yeah, what we want to do is to do the filtering. You can also do filtering in list comprehension actually. So remember, this will only give us the positive number. So what we can do here is that we can have x for x in my list 2 if x greater than or equal to 0. I think it's like this. Yeah. So you can add a condition at the end of the list comprehension, and it will basically do the filtering. This is exactly the same here. So yeah, this is very, very handy. For list comprehension, you can basically did what we did last week with the map and also filter. It works for both. And another thing that you could do is that you can even have else. So this is super cool. That so you can, so we'll just like modify our example. So for example, I want everything in my list, so I'm not filtering out anything. But what I'll do is that I would have so I'll have positive. So I would print out a plus if x greater than or equal to 0. So well, 0 is not plus, but well, whatever. Else minus oh, right, minus. So yeah, you can see that actually it works for if statement as well. So this section of it is kind of like a compressed if statement that you put an if statement in one line. So so you can use it. Actually, you can use it like by itself. So you can be like, you know, so like in a for loop. In a for loop, you can use the if statement by itself, right? So you can say like print plus if x, oh, oops, yep. Oh, what am I doing? Everything is so wrong. Okay, yeah. So you can use this if kind of compressed if statement by itself, which I think is the thing again. Like I forgot to talk about last week when I talk about the functional programming in Python. That for if statement you can also compress it, like your for loop. Like you know, is really really cool. Yeah. So what else is, so this is a very very good tutorial because it goes through so many comparisons and details that I really like. This is getting more complicated because you have list in a list, and then is, so you can actually use a list comprehension inside list comprehension. So this is what it's talking about. So I'm not going to run this example, but you can have a look yourself that, you know, so this is actually creating a list comprehension here in this highlighter thing here, and then you can do another list comprehension to compose it. So you have two, and yeah, it's just making two of them, and like you're using I, you can use I in here. This is super cool. Like you can even pass in this information here. Um, yeah. So this is the whole like tutorial here. In this you know, blog or something. I don't know. This is a, I think it is a website of teaching programming, and this is one of the entries. So this is super cool. The link is here in the slides. You can check it out afterwards and try it yourself afterwards. So yeah, this is list comprehension, and um, like also another thing for list, like I said, is ordered. So you can sort it. So in Python, there's a built-in function. I think we came across it a little bit before that. It's just called sort, and then you put in your list here, and then the cool thing is that you can put in a key here. So this key, if you don't put in anything, you just sort the things within the list, right? But if you put a key here, basically this key would be the thing that it would sort the list, and then well reverse, just like whether you want it ascending or descending. So another very cool tutorial is provided in, you know, the documentation of Python itself, that, you know, the basic would be like you want to sort a list, and well yeah, like the function is called sorted, but if, well, if you use it like, you know, you can use it as list.sort or you can use sorted, so they are the same. So yeah, so here is like the example here is sorted. So this is just sorting the thing because I didn't put in anything fancy here. Just use it, value to sort it. So yeah, you can see they are the same. And um, yeah, like for list or sort, so the difference is that for list or sort, it can only accept the list. But for sorted, actually you can put in any iterable there. But the funny thing is, in this example here, you can see that I put in a dictionary in sorted, um, but what you get back is actually a list, right? So this is very interesting. It's just like, it just take any iterable, because remember, if I iterate through the dictionary, it would just iterate through um, the key, right? So okay, I'll do some experiment on this one so you can have a better idea. So this is sorted, and then yeah. So for example, a dictionary like this. So I would call this my dict, right? So I have a dictionary, and then if I loop through it, right? So if I loop through it, um, oops, yeah, it's typing too fast. So it would just actually loop through the key of the dictionary. So 1, 2, 3, 4, 5 are the keys. So if you put it in sorted, um, it would basically, take all the values in this iterable and put it in a list, right? So you can actually remember that if this is range, uh, say 3, then you have 0, 1, 2. So actually here you can also put range 3 to get 0, 1, 2. So it accepts any iterable. It's just that it would take all the values inside, like all the things that this iterable yield. Hey, hi, someone saying hello. Yeah, Raphael. Hello, hello. Yeah, good to have you here. And feel free to ask me any questions if you have any questions. So yeah, like you can put in any iterables. So the value that this iterable yield, it will be put in the list. This is quite good because you can actually change any iterables into a list, and also, well, you can kind of sort it if it's something like this. I think if I put in, be um, let's be naughty. So 3 to 0 and then -1. So this one will give me 3 to 1. So sorry, I should copy this and put this in here. And no, not the colon. And it would sort it back into its order. So it would just take the value and then sort it. Of course, you can have reverse equals to false, then it will be 3 to 1 again. Or you can, use the key to sort it. But yeah, it would just use the value to sort it if you don't put in anything fancy, which is super cool. Right. So where were we? We were here. Okay. Key functions. This is what I'm talking about. So like you can use a key to sort things. For example, here it used, for example, I will just copy this example and play around with it a little bit. So yeah, so this is actually taking this sentence and then it will split it. So remember, if I do this, that what I will have is to have a list of the different words, right? So I can actually sort it according to, the alphabetical order, but it's gotta be lower. Yeah. The other thing I could do is to sort it by the length. So then it will be sorted by the length. Okay. Yeah. So this is very nice, I think. And yeah. So this is you can put a lambda function in it. Like for example, I'm just calling this default function, but what the other way you can do it is to write a lambda function, lambda, and then I will have x. So length x. Yeah, so this is doing the same thing. Um, so yeah, this is a very, I would say that like very useful when you need something like that. If you um, yeah, I can imagine like there are ways when I'm doing some like data handling that this is actually becoming very, very handy. Um, yeah, I can't just like think of it on top of my head, but you would definitely use it at some point. You would. So how I discovered it like a few years ago is like when I was like Googling how to sort things like according to something. So and then I just found this is actually a built-in function that is super powerful. Um, yeah, for example, you have two posts, and then like, okay, if I sort it, how am I gonna sort it? You have to tell sort it a way to sort it. For example, by age here, so by the here. Um, so yeah, again, like this is a very good thing to mess around. So let's put it here. Um, so yeah, like if we don't have this key here, let's take it away for now. And I think the default is just like take the first element and then sort it according to the first element of the first element, which is D. So D is greater than, just so this is just like alphabetical order for the word here, for the name here. I think, yeah, if you didn't specifically like say what you want to sort with, it would just sort with the first element. But if you put in a key here that, like, for example, I'm taking, again, this is a lambda function. So I have, so each one of these would be a student. And then for the student, I want the 012, the last element here to be used as the key to sort it. So yeah, then now it'll be sorted by the age. Is there any difference here? Wait a second. So there is not a good example, is it? Yeah, it's not a very good example, is it? John, Jane. Yeah, can I maybe I change the age of Jane to 18 to see if any different. Right. Yeah, so now it's like Jane is here, but if we sort it here, then Jane is here because it's sorted by name, not her age. But now here, then it'll be by age. Okay. So yeah, and then, well, if you have something more complex, and is this a Jupyter Notebook? Uh, this one is a Jupyter Notebook, and the reason why this is dark, kind of like dark mode-ish, because I'm using something called a Jupyter theme. So yeah, people ask me a lot, but I can't believe that this is not super popular because this is actually very handy. I really like that theme, and I like using Jupyter Notebook in my presentation, tutorial, whatever. And yeah, this is super cool. You can see that they have different themes. So yeah, it's called Jupyter Themes, and I found them on GitHub, and then you can know how to download it. Um, yeah. So right. So yeah, if you have something like more complex, it's like an object like this, then you could actually sort. Well, you can actually use the lambda function, so that's why lambda function is super cool here. But there's something even cooler afterwards. So what I gotta do is just to copy this student thing because I'm not going to create my own. So, um, oh, I put it wrong, is it? Oh, I put it in the wrong place. So no, it's not. Okay, right. I was a bit scared that I'm using the wrong notebook. So let me close it so I don't have to worry about it. Um, right. So, a we have this student object, and yeah, I really like the emoji there. It's so cute. Thank you. Um, yeah. So yes, student, and then like is there's like two method here. Or yeah, like you have done the init, of course. You have to start it, so you can have different attribute to store it. And then so representation here is actually a tuple when you print it out. So yeah, it's very, very simple, simple object. And then what we're gonna do is that, well, we can sort it using a lambda function like before, like this example here. But what we can do is that it could be even cooler that we could use the item getter and the argument getter. So item getter is basically just like the get item. So it would take in an index and then so it's basically the same as sorting by age, like the first example here, like this one. So it's like student 2, but you can just call the item getter here, right? And or You can get attribute getter, then you can use the name of the attribute, which is age, here in the student here. Oh, I forgot to create the student dictionary. Yeah, students object. I need those. So where are you? Here. Right. So let me put it in here. So yeah, I have the class student, I have the student object, and now, because like, this is name, grade, and age. So if I get the attribute of age, then it would just basically sort by these numbers here. Oops. Oh, I haven't imported, sorry. Yeah, so you can see that you have to import from operator. So yeah, operator is another like module that I don't know when I gotta talk about it. Maybe I'll talk about it like in another episode, but so far we just know that there's item getter and argument getter, and you can just use it rather than writing a lambda function. It's good to know that it exists, but I think that is not that big of a deal because you can always do things like we did before, writing a lambda function, and then I have student. Well, this is a standard for the student. Let's spell it out. Student dot age. So I can do it this way, right? So it's not the end of the world if you don't know the argument getter, but it's good to know. Okay, and what else? Yeah, also like you can also set the level of it. So this is the thing that is not that easy to do with a lambda function, that you can say like, hey, first sort by the grade and sort by the age. Okay, so you can have different order here, which is quite cool. So yeah, so that's why it's like really good to know. Like even though it's quite rare that you want to really be so specific about the order, but when you need it, then it's there. Ascending descending is just that if you have reverse equals to true, that it would be reversing the order. So for example, if you put it here, that now it's like 10 12 15, but if we reverse it, 15 12 10. Okay, um so complex sort, well, it sounds complex, but it's not really. So yeah, you just sort it first. Like the first time you sort it by age, and then you sort it by grade. So you can see that is, and reverse equals is true. So you first sort it like, so it will become 10 12 15, and then yeah, and then you sort on the primary key, which is the grade. So this is exactly the same as this one that we did with the grade and the age. Yeah, but it doesn't look the same because it was reversed, right? So yeah. So yeah, I won't go into detail here. I think you can read it yourself. It's just getting more and more detailed, and all these as well. Like, I don't think this is super important because this is kind of like a way that how people do it in the old times, and I rarely use those. So yeah, so I will skip over those and these. Yeah, so I think like the link again is in the slides, so you can read through them. But this is really cool to know that you can actually sort something not by its value, but by you know other means. Um, so yeah, this is super cool. And so now comes to dictionary. So I said dictionary is different, right? Because dictionary is not ordered. So we cannot just sort the dictionary and, well, you can sort it like we did before. You can sort it and put the key in a list, right? You can have different ways of sorting a dictionary, but the output will be a list. Otherwise, it won't make sense because a dictionary itself is just a blob of things. It doesn't have an order. So if you sort a dictionary and put it in a dictionary, basically you have done nothing because the order doesn't matter in a dictionary. So, for example, we can have a mess around here. Dictionary that so this part we can have a dictionary. For example, do we have an example here? Maybe somewhere that. So what was okay? So let's find the dictionary that we were using before. Where was it? I remember I have my dictionary somewhere. Yeah. Okay, yeah, here. So this is my dictionary, and what I gotta do is just gotta copy and paste again so I remember what it is. I have my dictionary. And then, so let's check if my dictionary is equals to, for example, I want to mash up the order. I just gotta change the order of things, and I'm gonna be taking this one and put it at the end. So are they the same, right? Remember, a list is not the same. So a list, a list 1, 2, 3 is not equals to 2, 1, 3, right? Because order matter. So now we have like my dictionary, which is like this, and let's check whether it is the same as this. Okay, it is the same. So the order really doesn't matter in a dictionary. So imagine we have something like this, and after we sorted it, it becomes something like this, my dictionary, and but in the dictionary it doesn't matter. So you didn't like, so it did nothing. So yeah, so what we gotta do? So we have to have an ordered dictionary. That order matters. Python have it, and it's provided through a collections module here. So let's have a look at it. So yeah, the thing is, like, in this ordered dictionary, there's two new method you could call. It's called pop item, which is like a list that you can pop out something. So yeah, and also move to end. So basically, you can arrange the order of something. Yeah. So this is the example. We have like so basically you create a order dictionary with the key A B C D E, and then you want to move the B to the end, and it will become A B D E A C D E B. Okay, because B is moved to the end. And yeah, so and then you moved again, like yeah, and then like you moved B again, but like this time you said last is equal to false, then it will be it will be moved to the actually the head. So it's the reverse of move to the end, which is funny. So it's move to the head. Yeah, but anyway. So also you have like reversed, that you can reverse the order of things. Yeah, and also this paragraph is saying that order dictionary, that the order does matter. So let's create an order dictionary and to see how things are going. So well, this is not a very good example because this is very complex. And what I gotta do is I gotta open a tutorial here that would give us a better example, or super small. Let me make this bigger. Yeah, it's not very like site friendly in my opinion. Right. So here, okay, like there's an example here that we have, you know, uh, apple, orange, banana, pear. Okay. Um, and it's a dictionary. So maybe I'll copy this dictionary just to use it as an example. So this one, okay. So again, like the order doesn't matter. So what I gotta do is that I want to create an ordered dictionary here. So I'll just do this exact same thing here. Oops. Right. So I gotta clean this up a little bit. So yeah, actually I don't need this because I'm assigning it. So yeah, so we have like we import the ordered dictionary from collections. So this is a Python standard library, so you don't have to pip install it. It would be like installed already with your Python. And so yeah, I have this. Oh, actually, I want to like show you how it will look like if I sort it. Okay, so if I just sort it, what happened is that I would just like yeah, I would just sort it according to the items, which is the this values of the dictionary, and this will be it, right? But so this is okay. Also notice that this come out as the list. Like remember, sorted will give you a list back. So what happened is that you can put this list in an order dictionary to create an order dictionary. Then you have a dictionary. that actually the orders matter. Okay, well, it looks very similar, but the thing is, like, for this ordered dictionary, you can do other things, like, for example, well, you can loop through it as if you loop through a dictionary. What you can do is that you can also use this reverse thing um, that is provided. But other cool thing is that, is if you compare the two dictionary. So okay, so I have new dictionary that is ordered by the items. Okay, so I will call this. How about I call this new dictionary? I want to call this um, item. So this is sort by item, and then like I can create another one. It's actually by key. So I have two, right? So now I can actually print out the two. So print. I have two dictionary this time. Right. Too many values to expect. Keys. Not S. Or maybe I can just like sort it D, then it will give me the keys actually. And oops. Two. Um, what happened? Let me see. And oh, okay. So like, yeah, it's not giving the thing, and um, yeah, it's not giving the thing here. Oops. Yeah, like I don't know why it's not giving the. Okay, let me do this, the items, and then what I'm going to do is that key equals to D, okay? Key equals to um, actually like the first thing of it, so lambda x, yeah, so it's kind of like this, yeah, yeah. So you can see that. Oh, sorry, like, oh, okay, sorry, it's a very bad example here. Sorry, correct myself. Yeah, so this is actually sorting already using the keys if you use items, because remember the default is actually taking the first thing to sort it, right? So if I call items, it will actually become a so okay, the items actually give me loads of triples. So remember the triples, if I don't specify anything, that actually it would just take the first argument here. So this is exactly doing this, but I can so this will be the numbers, okay? So this will be the this will be the item, sorry. Uh, yeah, right. So this is the num. So I want to how about I want to sort by this like 1, 2, 3, 4. So what I gotta do is that I gotta put this in here, and then I gotta take the first one. Yeah. So now you can see that okay, I have two ordered dictionary here. Sorry, I'm making a big mess here. So this will be sorted by the yeah, the number here, and the second one will be sorted by the apple, banana, orange, pear by alphabetical order. So are they the same? That's my question. Are they the same? So now because it's an ordered dictionary, because the order method, they should not be the same. Okay, so it behaves like a list. It behaves like a list. Um, right. So what else is that? Like for example, this one I can. Yeah, like it behaves like a dictionary. You can like still do this like you do with a dictionary, or you can have um, you still well, oops. Yeah, you can still do things that like that a dictionary could do, uh, slightly different. is slightly different because it's need to be ordered. But yeah, it's like basically is a dictionary that you got a superpower that you would preserve the order of it. Okay. Yeah. So this is how you're gonna have a ordered dictionary. You could actually create your own. You could write your own. You can read all this and create your own um, ordered dictionary. But uh, you know, why would you do that if you can just like call it from collections? So to finish the tutorial today, I have the last thing that I want to talk about is that in collections, there's actually another thing that is, in my opinion, quite useful. It's called countered, and this counter is amazing. This is super cool that it saves you a lot of times. So what it does is that, uh, well, you can create an empty counter. It does not do a lot of things. You can put in a string in a counter. So what it does is that, let's say, counter, and then, oops. So what it does is that, oh, I haven't imported, sorry. Yeah, so what it, oh god, what am I doing? My brain is not working well today. I don't know why. I sleep too much, maybe. Uh, did I spell it correctly? What happened to myself? Wait a second. Stop panicking. I'm rushing because, like, oh, it needs to be capitalized. Sorry. Yeah. Right. Now I created a counter with a string. So what happened is that it would just create a dictionary for me that basically count how many like occurrence of the letter in a word. This is very very useful, especially like if you're counting something um, like this, letter in a word. Well, if someone like those like interview questions, right? Like, oh, write a function to do this, and then the funny thing is like sometimes they would like you to write a function to do this task, and they'll be like, can I use anything else? Like, I can just actually call in the collections from the counters from collections, if they don't know Python, and actually you are basically cheating. Um, but this is super cool. You can also create a counter with a dictionary for sure. Um, Oops, it's not stopping you to do that. You can do this, and it'll create a counter with this. Or you could actually create a counter using this, right? Oops. Cats equals to 4 and dogs equals to 8. So yeah, it would just create it like this for you. This is like super useful. Um, in my opinion, you would come across this quite a lot. And yeah, so missing element will be considered zero. It will consider zero count, which is good because if it's just a dictionary, you would get a key error, right? So for thing that I'm missing, you'll just say it's zero. Um, yeah, so it's just assume that zero if it's not exist. And yeah, you can sort it by its element, and so yeah, like it would just like create iterator over the elements of it. So if you call c dot elements, it would just like expand this. So for example, here C is kind of a compressed form of all the letters, and it's just like, oh, there's one G and then 3A here. But if I do dot elements, then well, it will be a change, and if I want to have a look at it, I can change it into a list. Then what I will have is that I'll have all the letters back. It kind of expand again, like I'll have all the letters back, but the order is like, okay, 1G and then 3A, so it's A here. So it's not really ordered, but you can sort it now because it's a list. Okay, and then what else is cool about this? So most common, like there's a lot of like cool methods. So you can pick the most common three of them here, and it will be sorted as well. So let's say here I want the most common So C, most common 2 maybe. Um, so yeah, then I'll get the most common 2 from it. It'll be sorted and it'll be as the list, and you have the thing itself and the count as the tuple. And subtract, you can subtract the 2 counters, and then you would have what's left. So yeah, counter is super powerful and super cool. You can also from keys that oh this oh no, this is not in there, yeah, because like yeah, like there's no use for that. Except for yeah, so like everything in dictionary is in counter except for from keys, because well, it's just not useful for it, so it's not implemented. And update, so it's not there. But otherwise, it just works like a dictionary. It acts like a dictionary, and all these things work for it. Like you can have values, you can change in the list, change in the set, change in the dictionary. Yeah, you can do a lot of things with it. So and also you can have operations that's adding two together, and you can also minus. So and so this will be union, and yeah. Oh no, this is intersection. Sorry, and is intersection or is union. So you have all these operator available as well, and yeah, and well, because you have like addition and subtraction, so basically you can have a plus and minus in front of it. So it will assume that you have an empty counter to add and subtract. So yeah, so yeah, this is counter, and this is very very useful in lots of cases. That's why I think it's worth a shout out for them. It's basically a dictionary especially designed for counting things. The good thing is that when you create it, it will just count everything for you, which I think is very, very nice. So I think that's it for today. And next week, I have no idea what I'm going to talk about yet. But I think that the chances are what I'm going to do is to maybe talk about subprocessing or path or OS, like all these kind of more like have a specific like standard library that would be useful. So yeah, maybe like OS path, like OS and subprocessing, things like that. That you could actually basically like using your command line in Python. But I am not feeling strongly that I'm gonna talk about it yet. I'm just like having an idea. So if you have anything that you want me to talk about, let me know. I can be contacted by Twitter, and also like um, yeah, just find me. I think the best way is Twitter. If you kind of know me from somewhere else, you would also know other means of contacting me. But Twitter would be the easiest, I say. Um, Otherwise, I would see you on Wednesday. So tomorrow, actually, I'm taking a break tomorrow because tomorrow is a holiday in UK, and recently I'm not like feeling super well personally, kind of like mentally. I need I need to be easier on myself. Let's put it this way. So I want to take a break tomorrow, and um yeah, and then I would definitely see you on Wednesday again. And also I'll be speaking at PyCon Australia, which is happening next weekend. So yeah, it will be a busy week for me next week. So that's why I think it's good to take a Monday off, so I can have some room to breathe and kind of caring for myself. And yeah, I think that's it. I will see you, and yeah, we have Jasper with us on Wednesday, which will be very very nice. Yeah, like it will be great. So I will see you on Wednesday. Bye.